Okay, so today we're going to be taking a look at achieving silence. So now when people build computers, one of the important factors to consider is your cooling efficiency. Now personally, when I'm building a computer, I'm more concerned about silence. Yes, cooling efficiency does play a factor, but I'm one of those that when I'm playing my computer, I don't want to hear the fans ramping up at 2,000, 3,000 RPMs just to cool it. And typically, what I will do is I will get a decent enough cooler that I can lower my fan curve, still maintain good temperatures, and not worry about thermal throttling or performance loss. And today we're going to be talking about that, going over TDP, what it is, thermal throttling, and what can we do to kind of help ensure that our computer is running efficient, it's not thermal throttling, and we're not losing performance on it. So we're going to be taking a look at this build that I just did. This is my personal rig, and when I had built it, I went with this cooler, and we'll talk about that. And although this cooler has been great, I haven't been happy with it for the simple fact that the fans have to ramp up pretty decent, and it gets a little agitating, when you're gaming right next to it, or pretty much when you're encoding or doing any type of load on that. So we're going to be swapping out the fans, talking about the fans inside this case, and coming up with a way to still get good cooling efficiencies, keep my fan RPMs low, and enjoy my computer experience without going deaf or agitated with these fans. And these fans can ramp up pretty high. When we're talking about sounds and these fans, they're measured in decibels. Now, when you're in an office or a normal workspace environment, or even like a living room home environment, the average decibel there, according to some websites I've read, is about 50 to 60 decibels. Now, I was looking at a couple of websites, and they said an enjoyable computer gaming experience, usually you want to stick to 30 to 40 decibels, 30 being ideal. Anything less than that is pretty much perfect. But like I said, when you lower the decibels, you also have to lower the RPM of the fan, because that's actually what creates the noise. And when you lower it, you do lose cooling efficiency. Now, if you use decent fans that blow a lot of airflow, that will help keep the cooling efficiency efficient, but also keep the decibels in a reasonable range where it's not aggravating, to say the least. So now, with all that heat being generated, you run into something called thermal throttling if you don't have an efficient cooling system to keep up with the TDP. That's when your CPU or your GPU, it takes on a heavy workload, like I said, such as gaming and stuff, and it generates a load of heat. And what happens with thermal throttling is that your cooling solution can no longer dissipate the heat fast enough to keep up the temperatures within safe range. So the CPUs and GPUs, at least most modern ones, have this safety in which it will downclock and reduce the power frames. It would reduce the powers, the frames per second. It would reduce core clocks, memory frequencies to begin dropping the power usage, so it can lower the temperatures to help preserve the CPU and GPU and keep them within a safe operating range. So an example of that is like you've had a computer and it's been around for 5-10 years, and the computer all of a sudden is just running real bad. You open it up and it's covered in tons and tons of dust bunnies. The thermal paste is dried up. So because the cooling efficiency has been compromised, the computer is actually downclocking it. An example is like if my CPU cooler cannot keep up with it, what it will do is the CPU will actually downclock itself to 3 gigahertz, 2 gigahertz until it can actually put the CPU in safe range. It's kind of like a self-preservation, to say the least, on it. Although, thermal throttling helps save the CPU, it's not a long-term solution because the heat can damage and shorten the lifespan of your video card or your graphics card. So if you're having thermal throttling, you need to address this issue, or you're going to end up degrading your components. So now I'm changing out the fans, and this is the Corsair 4000D, and it actually came with these fans over here, and I'm not a huge fan of these fans. They are loud when they ramp up, and when they loud, they create a turbulence noise. Now, they're efficient at blowing air, but the noise on it, I'm not a fan of it, so we're definitely changing these out. I also had these maglev fans, which these fans are awesome. I can't really say anything bad about these maglevs. They are amazing, but I like to stick to the same brands. I don't like mismatched fans. It's more OCD. Is there anything wrong with mismatching your fans? No, but I'm OCD and I want to keep the same look going on in my computer, and we're switching these out. Nothing bad against these maglev fans, but we're going to be going with the Be Quiet Silent Wings 3, and they're 140 millimeters and a 120 millimeter over here. So that's what we're going to be using just for my OCD. Now, just to kind of talk a little bit about these fans, these are the Be Quiet Silent Wings 3. They come in 120 and 140. I believe that's what they typically come in. I don't know if they make anything bigger. It's the mounting hardware that they use. They're rated as having a great performance to noise ratio, with 28.6 decibels being for the 120 and 28.1 being for the 140. Typically, larger fans spin at lower RPMs. The max on these, the 120 is 2200 and the 140 is 1600. And because they spin this probably similar amount of airflow, and because they're bigger, the noise is going to be reduced on them when you're going from 120 to 140 on it. So they're fluid dynamic bearings, and apparently the frame, I guess they talk about it, is like a funnel shape, which I guess I could see it a little bit on it. I don't know how well you can see it, but it allows more high air pressure. Now the Silent Wings ones are better for case airflow fans, and the Pure Wings are actually designed better for like using radiators and stuff like that. At least that's what they say on their website. It's 4-pin PWM controls, and they have 7 blades on them. So these are the fans I'm going to be using. I'm going to unbox the 140. We're going to go ahead and install them in here, and then we'll talk about the CPU cooler. So what kind of sparked this video and upgrading my fans and CPU cooler is that the other day I was using this computer, and I've used it before for a while, and while I was doing some editing and even some some downloading, my temperatures were spiking. And the reason why I knew they were spiking is because I started seeing some performance loss. My editing times went up, my download started I started losing download speed on it, and thought it was weird, something was going on. So when I ran hardware info showed that my temperatures were like spiking up to the 90s, sometimes higher. So the CPU, to preserve itself, needed to downclock itself so that it could get the temperatures manageable. And then when the temperatures got manageable, it would spike up again, and yeah, never-ending saga on that. So why are my temperatures spiking so much? I like to keep my fans around 700 to 800 RPMs. I've done that for years, and I've always had an efficient cooler. I guess when I bought this cooler, I didn't take that into consideration. So by keeping my fans over there, they can't keep up with dissipating the heat from the workload that I'm using. And when I do the stock fan curve and I increase it to what is supposed to be full speed under high loads and all that stuff, depending on the temperatures, the fan noise was not pleasing to me, to say the least. And I'm very big on having a quiet gaming experience. Now some say AIOs are more efficient at dissipating heat. I'm more big on CPU coolers, so I figured getting a bigger CPU cooler and quiet, more efficient fans, I should be able to keep my fans about 700 to 800, maybe even 900, and be able to dissipate the heat more efficiently in the case and off the CPU. So size does matter. And take a look at these two things. They're both Be Quiet fans. We got the Dark Rock Pro 4, and we have the Dark Rock Slim. This one's 180 watt TDP, and this one is 250 watt TDP. So you have, 75 more watts? But if you look at it, I mean, even in comparison, it's pretty much two of these stacked up against each other. I love this cooler. It's actually great. And when I had my 8700K build, I had to give that cooler away with it because, well, I lost the mounting bracket. But these are like $89, and this one is $50 over here. So yeah, should have went with this one, but learn the lesson. You live, you learn. Now with this one, it's rated at 23.6 decibels, and I believe primarily because it only has one fan. This one's 24.3 decibels, but because we have way more heat pipes, way more fins, and all that good stuff, I think we should be able to dissipate the heat a lot better, still keep our fans at 700 to 800 RPM, and still keep within that 30 decibel noise, and even under heavy loads, it should be able to keep up with cooling the computer efficiently, so we don't get no performance degradation and run better. So I'm gonna go ahead and install it, and then what we'll do is we'll do some AIDA 64, we'll do some real world stress testing on it, and we'll see if the size and the higher TDP with the same fan RPM helps improve cooling efficiency and also keeps that low noise, which I enjoy on my computer. So my cooling efficiency has improved greatly. I'm still keeping the same fan curve, and I'm still keeping 700 to 800 RPMs. We have a beefier CPU cooler that's able to pull the dissipate the heat a lot better. We have our two 140s over here, our 120 in the back, so we have good airflow, and these fans have great airflow that is definitely able to move the heat out of it over here. We're doing encoding and some downloading over here, and if you look, my temperatures are sitting at 77 degrees compared to before where I was spiking up to 90, low 90s. Occasionally I would hit the mid 90s, hit thermal throttling, and then the CPU has to downclock itself to kind of help preserve itself from pretty much frying. And we definitely achieve our goal. Now if you listen, it's quiet. I'm running a full load, and this thing is nice and quiet, and it's definitely running efficiently, and I'm very happy about that. So something for you guys to consider is that if your computer is running really loud, but if you're really looking to get the noise quieter, you definitely want to make sure that you have a good CPU cooler, good fans, good airflow, and you could lower your fan curve, still keep within a good thermal limits, and have a quieter computing experience. My computer is set up in the living room, and when I have the family and everybody over here, it's quite agitating before that everybody's out over here and all they hear is my fans going like 100 miles per hour. But now we're able to keep them in check, in tune, and they run great. And another thing, if I wanted to start doing some overclocking, which I might do later, I might up the fans maybe another 20 to 30%, which will still be manageable as far as the noise that we're trying to avoid, and I could get some better overclocks with this. As far as before, I had to run the fans at full blast all the time just to keep the temperatures manageable if I decided to do an overclock. So something for you guys to consider. So definitely comment down below. Let me know what you think as far as your experiences with thermal throttling, fans, CPU cooling efficiently. If you liked the video, definitely hit the like button, subscribe if you're not. And as always, we'll see what we come up with next.